So all of your notes for today, with the except, actually even this one's on there too.
What?
All of your notes for today are in the pink packet that you got yesterday.
Are we doing notes?
If I am not mistaken, this warm-up problem is number 2 on the stuff that you should have done last night. No, you were supposed to do the first and the second page last night.
I didn't understand number 5. Are we
Okay? So let's make sure that you've got this one done, and in about 2 minutes I'll go over it. Alright, so our goal, or your goal I should say, should be to get all of your trig functions down so that you only have one. So you either want sines, cosines, tangents, cotangents, secants, cosecants, all of them. And you don't want to have any double or halves or sums of or differences of angles in there. So if this were me, I would take this cosine squared and I would make it 1 minus sine squared. I would apply the hammer to it. Then I would also take this cosine of 2x, and now according to number 22 on your reference or on your identity sheet, you've got 3 choices. We could go with cosine squared minus sine squared, we could go with 2 cosine squared minus 1, or we could go with 1 minus 2 sine squared. I'm going to go with 1 minus 2 sine squared because that now gives me nothing but sines in my problem. Okay? Then I'm going to subtract 1 from both sides. At the same time, I am going to add 2 sine squareds. That gives me sine squared plus sine equals 0. Now I can factor out a sine. Now I can set my 2 factors equal to 0. On my unit circle, where is sine equal to 0? That happens at 0 and pi. On my unit circle, where is sine equal to negative 1? That happens at 3 pi over 2. I was trying to get through 3 pi over 2 and then sneeze, but it didn't work out. I tried. Okay?
You could use multiple ways, right?
What do you mean?
Like, the way I did it, instead of, I converted cosine to cosine squared as minus sine squared initially.
Okay. Then what?
Then I subtracted cosine squared from both sides and added sine squared.
And then that got you, and that picked you up at this top line blue? Yep. Yep. Agree? Okay. We are now on the 3rd page of your pink packet, where we find the half angle identities. Okay? So this is yet another way to find exact values of non-unit circle angles. Okay? So the sine of u divided by 2 equals plus or minus the square root of 1 minus cosine of u over 2. That is number 24 on your identities page. And then the cosine one is number 25, and tangent is 26. Now, you'll notice too that on your tangent one, on your identities page, we have an extra identity on there for tangent of a half angle. But that's kind of a nastier type one because it's a square root one. Okay? One thing that I will also draw your attention to on these formulas is the plus or minus signs that we have going on in the sine and the cosine one. And that is going to be determined based off of where your angle is. So for instance, I'm going to come over here to our unit circle on the window. Okay? So if I am dealing with the cosine at 105 degrees, that would be right here. I could say, well, 105 is half of 210, and 210 is now on my unit circle. So that's why I'm choosing 105. Okay? But the cosine of 105 is negative because I'm in quadrant number 2. So therefore, when I go to utilize my cosine, I would have a negative sign, SIGN, in front of my square root, because cosine is negative in quadrant 2. If I was trying to find the sine of 105 degrees, I wouldn't have to put that negative SIGN in front of it, because sine in quadrant number 2 is positive. Okay? Do you understand what I'm saying with that? Clear as mud? Okay? So you have those in front of you, provided having your identity sheet out. Let's go to town on them right now. Let's try one of each. We'll try a sine, a cosine, and a tangent. Okay? So the sine of 15 degrees would be the same as, since 15 is not on my unit circle, the sine of 30 degrees divided by 2. Agree? Yeah. Well, I'm going to utilize my half angle formula, which is number 24. Where is, or I should, let me instantly rephrase this question. What quadrant is 15 degrees in? Quadrant number 1. Is sine positive or negative in quadrant number 1? Positive. So I'm going to have a positive value here. Big square root 1 minus the cosine of 30 degrees, all divided by 2. What is the cosine of 30 degrees? Cosine of 30 degrees. Square root 3 over 2. Agree? So now I have fractions inside of fractions, inside of radicals, inside of ugly stuff. Okay? So if I look at just my numerator, have that, correct? Okay. How can I combine those two? How can I add or subtract those two? What do you need? Common denominator. What's my common denominator going to be? 2. So my first fraction ends up becoming 2 over 2, and my second one doesn't change. So then that becomes 2 minus the square root of 3 all over 2. Would we agree with that? Okay. All of that is still being divided by 2. Dividing by 2 is the same as what? So that fraction is really what? Over 4, yeah. When I take the radical of a fraction, what do I do? Or what's one of the rules when I am taking the square root of a fraction or any radical of a fraction? What's the rule? What's the rule? Radical of a fraction. Oops, almost put 5. Okay. So this becomes what's the square root of 4? Dividing by 2, you told me already, is the same as multiplying by 1/2. So the sine of 15 degrees is 1/2 times the square root of the quantity 2 minus the square root of 3. Which, if we do the sine of 15 degrees on a calculator, what would we get? Sine of 15 degrees is Anybody? Sine of 15 degrees. One half times the square root of 2 minus the square root of 3 is the same thing. Okay? Radian measures now. Okay? Cosine of pi over 8, well, that's the same as the cosine of pi over 4 divided by 2. Cosine formula in half angle formula was plus or minus square root of 1 plus cosine of u divided by 2. Pi over 8, which quadrant? Quadrant number 1. Cosine positive or negative in quadrant number 1? Positive. So this is also going to be positive. Cosine at pi over 4. Simplify the numerator. Simplify the fraction. Square root top and bottom. And I get the cosine of pi over 8 is 1/2 times the square root of the quantity 2 plus the square root of 2. Questions, comments, concerns? Tangent now. You have 3 choices to choose from for tangent. Which one looks the easiest?
The
the second one right here for me? That one? Okay, let's utilize that one. Easier denominator. Okay. So this is the tangent of 7 pi over 6 divided by 2. So then that would be 1 minus the cosine of 7 pi over 6 divided by the sine of 7 pi over 6. Cosine at 7 pi over 6. Sine at 7 pi over 6. Numerator is really 1 plus the square root of 3 over 2 because it's minus a negative. Would you agree with that? Okay. So then that becomes 2 over 2 plus the square root of 3 over 2, which is just 2 plus the square root of 3 all over 2. Still being divided by negative 1/2. Dividing by a fraction flips and multiplies. So 2 plus the square root of 3 over 2 times 2 over negative 1. 2's. Cancel each other out, leaving me with the tangent of 7 pi over 12 is equal to negative 2 minus the square root of 3. Yes, indeedly do. What I'd like you to do for the remaining 7 minutes now is I would like you to do the other 3 problems that we didn't do on that page. While you're doing that, I will be coming around and I will be handing out the review assignment for your test next week, Wednesday.